Today I'll be tackling the Amazon S3 as a service. And what is Amazon S3? It's a simple, just an object storage to store your objects and data in the S3 bucket. And then for the purpose of, you can store and then you can retrieve data anytime you like. For the features of Amazon S3, we have like durability, like for the S3 service, it offers a 99, it's 11 nines of durability, and then high availability, which is about 4 nines of availability. Security, we have like the server end encryption and the key management service for security purpose of our objects and that will be uploading in the bucket. And then it has unlimited scalability, whereby it can scale and also be flexible in terms of duplication. And it also has the low cost. With the upfront investment, it is a cost-effective feature. For the use cases, it's mainly used to host application. And for our demo, I'll be doing a demo about how to host a static website using the S3. And then you can also use it to store, backup and for storage if a company or an organization has large data. And also for the media hosting, software delivery, and the static website. We realized that features the types of URL to access our buckets. We can use the virtual hosted style or the path style URL. The difference is just that the bucket in the virtual, the bucket comes immediately after the HTTP. And then Amazon S3 is a public service and can be accessed via the public endpoint. And the objects attributes, we have the key name. For the key name, our bucket should be unique, so that it's supposed to be globally unique. And then the version ID. The version ID is to identify, to differentiate the different version of if you have a same image, and the other image is a bit higher version than the one before, so you can differentiate between the two so that you cannot overwrite or delete your previous data, your previous image. And then the value is all about the content of our object, the metadata, and also sub-resources. The sub-resources are the one attached to our object or to our bucket. Access control information. By default, the objects are mainly accessed by the users who have explicit access to it, privately that is, so you cannot access if you don't have access to the objects. S3 gateway endpoint. So it provides a way of S3 request, and it is routed through the S3 service without connecting your private subnet into the internet gateway. So as you can see in our image here, the S3 bucket, the EC2 instance is able to access the S3 resource through the S3 gateway endpoint. Is not a must if you connect it to the public subnet. And then what is a policy? This is associated to our object. So this one is an example of the policy. It has the version, the statement, the SID, the action, effect, and resource. So when we will be doing a demo, we'll get to know more about this. And then the identity-based policy, they are attached to IAM user group to let us specify the permission that you're supposed to do with our S3. So for instance, here is the IAM user and then the inline policy. You can also write a policy that will attach your S3 to the IAM group as one, and then also the identity policy of the IAM role. And then to the resource, for instance, the S3 bucket, you can attach our policy to the bucket. Yes, so this is the architecture diagram that we'll be doing the demo. We'll be having two files, the correct URL, which will say welcome to WSLab, and then the wrong URL. So without wasting much time, I'll just proceed to the demo. Okay. So we are creating a new object, a new bucket. A minute, please. We'll be navigating to our S3. I've already logged in. And then we create a bucket. The bucket should be unique. So let me put something that is unique. Not sure it's unique. And then we choose the region. By default is US East, Northern Virginia. And then this one is optional. To block public access settings for this bucket, you're supposed to uncheck here, and then we confirm that the setting may result in the bucket, and the objects will then becoming public. So like we want our object to be public. And then for bucket versioning, okay, for this demo is not a requirement, so I'll just proceed to creating a bucket. So yes, here is our bucket. And then if I click the name of our bucket, we're supposed to proceed to properties. And then you're looking for the static website. By default, the static website is disabled. So to enable it, you're supposed to edit and then enable. I have two documents that will be uploading to our buckets, the index.html and error.html. And then we save the changes. So we are supposed to copy this URL that we will be using it to access our file. Let me just copy it. And then now we upload our objects. So we have the error file and the index.html file. Yes, it has already uploaded successfully, as you can see here. So the next thing we're supposed to close, we go to permission, we edit our bucket policy. Our bucket policy is generated by default, but you're supposed to edit it so that it can match. So here, for the bucket ARN, you're supposed to put in the resource field. So I'll just copy this, and then that's for our principal, it's supposed to be, we are allowing all. So I'll put this. And then for action, we get the object. I'm not sure it's conform. Yes, is S3 get object. Yes, that too. I think you're also supposed to put this. And then we generate our policy. So like our bucket is publicly accessible, and when we try to follow our link, it brings the message of that the file, and then when we add here URL that is not recognized, let me say this. Yes, it shows the file indicating the error HTML, that the page is not found. Yes, again, that's all about my presentation. It was a short one because it is my first time, and next time we will focus more about versioning, application, yes, and my MFA delete. Back to you.
All right. Thank you, Adeline, for your presentation. Do you have any questions for Adeline? Anyone? So, Adeline, would it be possible to deploy or use S3 for any kind of website, say WordPress or any static website like 11T with a different CMS? Would that be possible? You're on mute. Sorry.
Oh, sorry about that. Yes, it's possible.
All right. And then Jaira have a question regarding on the bucket policy resource. Aaron,
Yes.
is there a difference if I place asterisk at the end? So she said an example there.
It means that you're supposed to provide the all. It's a wild card. We provide the all the resources, the files that we have in our bucket.
I see. Jaira, were we able to answer your question? Just
Okay.
put a message if I, okay. There's a follow-up. There's a couple of more questions. It's like static web hosting from
Yes.
yes, okay. And from Jaira, there's a follow-up question. Does the first one access only the bucket and not the objects inside?
Okay, it accesses both the bucket and the objects inside the bucket.
Jaira, is that okay with you already? Very good. Yes, she gave a clap. So I guess it is. Adeline, if you don't mind me asking, since AWSUG Build Hers Plus is about diversity, how did you get into your role? How did you explore building your expertise on AWS?
AWS, okay. This program about Azubi Africa. It's led by Marine, and they were offering training 3 months. So I started my certification when I was still in my 4th year. That was last year, May 2021. And then after that, I did the exam at around August. And then I proceeded to do solutions architect. I did my exam early this year, January. Yes, okay, it's sort of a scholarship they offer Kenyans so that they can pursue their course in AWS Cloud. Okay, I have another certification that I'm supposed to do, but right now it's pending because of the job that I'm doing. It's so demanding. And I also have another scholarship that I'm working on. It's about software development. Yes, and it will be ending in late June this year.
So what you're actually encouraging, to our attendees, not just to women, is to take advantage of programs like, what AWS is actually offering. So, for example, there are free certifications or free, free certifications and web labs rather, or events like this. So take advantage of that, get scholarships if there's any that is available in your country or city or area. But being part of a community like this is actually very helpful if you want to build your capability or expertise. I guess that's an advantage in your end because you're part of the user group, or you're one of the organizers of AWSUG Kenya also, right?
Yes.
Okay. Geoffrey has a question. Can I also host a website built on Python on Amazon S3?
Yes, it supports the all, I guess about it, there are many programming language that supports S3 bucket. So it's possible to host Python based because it's a web application, yes. I'm not sure about the Android.
I see. So Python, any Python application can be, any website built on Python can be actually hosted on S3.
Yes.
Okay, last call. Does anyone have a question for Adeline? Any tips or advice, Adeline, that you can give?
Tips to everyone.
Yes.
I'm not sure. To continue learning, to utilize the free opportunities like this AWS Skill Builders. They have great content. Cloud Academy. We have Labs. Yes, because right now, like, because of the job that I'm doing is not related to AWS, and anytime I'm feeling my knowledge is fading away, so like I have to create some extra time and go through my notes and to do the labs. Yes.
All right. Thank you. Thank you, Adeline.
You're welcome.
Okay. So in any case that you still have questions for Adeline, you can use the chat box to ask her questions and she'll try to answer it. Are you gonna hang on for a little bit, hang out rather for a little bit, Adeline? Okay. And now we're very excited to have our second speaker. For our second speaker, we have Mr. John Doyle from Cambridge, Massachusetts. So it's quite early, I would guess. How early is it, John?
Just after 7 a.m. I have my coffee in hand.
Oh, great. So John has been developing solutions for the past 15 years, from large organizations to small startups. He enjoys sharing what he has experienced and learned, and from building multi-region solutions to tasting whiskey. Is your coffee have any whiskey on it? Or too early for that,
So
John?
keep it a little bit easy today. Just a little bit of caffeine.
All right, without further ado, would like to welcome Mr. John Doyle to AWSUGBuidlHers Meetup this month of May. Thank you, John, for accepting our invitation.
Thank you very much for having me. So hopefully you can see my screen now.
Yes, we can.
So I'm going to cover what I was calling serverless processing near and far. And we're going to deal with this with DynamoDB to store our data, and then the actual processing utilizing AWS Lambda. So the very first thing we have to ask is really then, what is DynamoDB? So it is known as a fully managed key value NoSQL database. This lets us set, for instance, a primary key and store whole JSON documents with it. Now, by default, your DynamoDB tables are region specific. So I could create a table in my account here in, well, I guess in Oregon, really. And then we could have another one in Mumbai. They could have the exact same name, example in both of them, and there's no conflict. They're all just region bound. Then one of the great things about DynamoDB is that it is very scalable. By default, it utilizes on-demand pricing. So this means that there's also pay per request. You can then configure the capacity that you want the table to respond to. So like, you know, if you only wanted to spend so much money, that's easy to implement. Or you can decide that you can create auto scaling and it will just like scale based on demand. Great for us. But again, we need to go from our one table to actually global tables. And the first step along that is DynamoDB streams. Now, this is basically a time-ordered sequence of events. As you create, as you update, as you delete data in the table, it will be assigned a sequence number and be put into a queue. You may be familiar with what is known as FIFO queues, first in, first out. They're processed in the order that they are received. So every event, whether or not it is, as I said, like inserting, deleting, updating, they'll be put into this queue and they'll stay in that queue for 24 hours. And we'll use this stream effectively to replicate our data globally, but we'll also use it later on when we want to start processing data changes. And so this is like taking our data from just being a regular database and moving into more of an event stream. So this then brings us into the global data tables. Now, one of the big things, obviously, we have to deal with a global table is multi-region. One of the great ideas behind this is that when we were building out with data centers pre-AWS, a common pattern would be that you would have one primary database and you'll have your secondary database or data centers effectively. And so one would be live, your data comes into your primary and it will replicate over to your secondary. And so if there was ever an issue in your primary one, you'd simply do a DNS flip and your secondary would now be live with a minimal amount of downtime. Thankfully though, this is what we start to get now with our global tables. But DynamoDB global tables gives us one extra major thing, and that is a multi-master replication. This means that we don't have primary and secondary, rather we have two primaries, or up to, I believe it's 17 primaries maybe, with all the different regions that support it. And so as changes come into our Ohio table, those go on to the stream, the queue in Ohio to replicate out. Similarly, any changes that arrive in Ireland or Mumbai or was it Singapore and so on, they all get like replayed against each other, all the other replicated regions. While this sounds like it should take a while, the latency is only around about a second. And then for our developers, the best part about this is that it is effectively native. So this is all handled within DynamoDB. There are no application rewrites. If you are already using DynamoDB, you could simply hop into the console and just enable DynamoDB global tables, tell it which regions you want to deploy in, and away you go. Now, while we could do it through the actual console, I'm a big fan of what is known as the AWS CDK. So this is AWS's infrastructure as code framework, and it makes creating global tables incredibly easy. As you can see here, this is within 5 lines of code. You've created a DynamoDB table, and you've given it its primary key. In this case, we've called it ID, and it's a little bit off to the side, but that is of type string, and then a replication region. So when we deploy our AWS CDK constructs, it is deployed in one specific region. That'll be your primary region for it. And then in this case, I have deployed it into US East 1, but it already knows, okay, it should also be in US East 2 and US West 2. All this code will be available on GitHub later on after the talk. So let's actually see this in action. Now, one of the things I will say about global tables is it does take a little while to actually set up or to deploy it. So I've already deployed that. There's no magic here. So let me hop over and change screens and terminal. Great. So here we have was it DynamoDB. We're going to run an example against a table called example. This is in terms of US East 1. Right now, there's no data in there. Great, thankfully, and returns 0 items. Now I'm coming in here, and I'm also going to insert into, actually, let's change that to US East 2, actually. So we're going to insert data into US East 2, into the same table name example. Kick that off. Let's go back here. Let's see how quickly did it get over there. Great, it's already in US East 1. We went to US East 2, exact same data again. And even in this case, I put it into 3 regions. Should hopefully see it again in the 3rd region. Now, this is the great way of quickly getting your data out into multiple regions, syncing it up, making sure it's all in sync. But it doesn't really help us in terms of processing yet. So I'll hop back over to the actual presentation, and that's where Lambda comes in. So what is Lambda? Similar to Dynamo, this is a serverless service. So this is their compute service. And it allows us to develop and run code without needing to worry about provisioning or managing our infrastructure. A lot of very easy to just quickly deploy some code up there. One thing you do need to worry about is your runtime language. So there's a bunch of languages that are supported by default. In the GitHub repo, you'll see I use Node.js. There's a bunch of other ones that it supports natively, like Python and so on. It also supports Docker images now in multiple regions. So if you can run it in Docker in those regions, you can just run it in Lambda now. Whether or not that's right, that's a different talk. And then one of the obviously big parts about AWS is that secured application security is on our shoulders. And again, with Lambda, we are able to provide fine-grained access controls, like explicitly stating, okay, this Lambda can read from this table, but it can only write to that table. So we're always very good about that. And again, I'm going to quickly now demonstrate how this can look, actually. So this bit of infrastructure here, we're going to have an input table where we're going to actually put something in. We're going to have a function actually then read that change. It will then do a little bit of manipulation and we'll save it into another global table. So we have our input, output tables, and let's see. Oh yeah, sorry, we'll actually go through it. We have our actual input table here. Again, same idea. We're in 3 regions. We set the name and the actual like ID. We then actually create our Lambda. So our Lambda, we do need to actually stipulate, like, for instance, what is the table name in that region that it's going to actually be writing to? And then we actually give it permissions. Okay, you can write to the output table. You can read from the input table stream. And again, in only a handful of lines, we're actually stipulating, great, there's now an event source. This will now be automatically triggered when a change occurs in that table. Another quick demo, sweet times. Maybe going too fast, I apologize. And so in this example now, we can start off, again, I've now 2 different tables. One is example input, and one is example output. So our output table currently has no actual changes here, no data there. We put this in though now. This may take an extra second or so with the processing, but let's see. Oh, we already have it. So you can see here that it arrived in and actually like put in the region code, the original ID, source ID. So that came in from here. And we also gave it a unique identifier effectively here. So we were able to like pull the data in, make a quick change, and we can even quickly look at that code change here. So if we go into Lambdas, Lambda mix.js, all we're doing is we're pulling a request, is hitting our Lambda. We're extracting, for instance, like what is the source ID, the source region, what the table name is, which is what we passed in. And we're actually just giving it, great, write this all to the actual like output table, give it a new ID. So because this is DynamoDB, we still don't want to have any conflicting data and so on. And you can design your table around this. We put in the region that the actual Lambda is running in and the source ID. And so it's a very simple, like quick example of what we can actually leverage in a number of different needs. Let me see, go back to this. Yeah, so for instance, utilizing this type of architecture, having it in multiple regions, processing in the specific region, you can you might be able to leverage fault tolerance across regions. Like I'm in US East 1, there are often times in US East 1, and it's great that we could also have our data be running in another region. There are other times where we simply want to segregate our data based on geographic regions. One of the jobs, or take like Uber or taxis and so on, the idea is that they should only need to see actually jobs in their immediate vicinity. There's no reason that someone in New York needs to look at anyone who's looking to get a ride in San Francisco, for instance. And so you could just segregate the data again that way. A big one that we often deal with is in terms of data privacy laws and regulations. You might need to have like GDPR in Europe. You might have to host all of the actual European client data within that region. You might, again, similar with like the US. And so you can have the data bases separate, running the same code and so on. And when you need to make like any specific call that hit all your users, you can again use this type of event stream to actually like trigger these type of changes. I ran through that quite fast, so hopefully there's a few questions after this. Sorry. There is the GitHub link for anyone who wants to actually like download the actual code base and review it. But yeah, if anyone has any questions, I'll happily answer them.
Wow, thank you, John. We really appreciate that you even have a demo, actually. All right, let me check our chat for questions. Does anyone have questions for John? John, while we're waiting for questions for you, I wanted to ask, like, how did you get to start using DynamoDB? Was it because of your projects at work, or you simply wanted to explore how you use it and then you recommended it to your company or something like that?
Oh yeah, so I would say actually one of the ways I really got into DynamoDB and AWS, I'm a big fan of doing, for instance, like online hackathons and so on. And one of the great things about DynamoDB and Lambda and API Gateway is that when you create a new AWS account, you get a lot of free credits. And so like for doing quick projects, being able to build out these type of resources for free is a great way of either implementing quick personal projects in terms of like quick hackathon weekend. You're like, great, okay, I can see if I can bang this out, or just low cost to implementation. As you got more used to it, you were able to see when did it work. A lot of our work would utilize more traditional relational databases, but when we started seeing the projects that would actually benefit from events and so on, that is where we actually started going towards more of a DynamoDB and Lambda based system. And there's been, I'd say, about 6 or 7 different projects that we've found that that it was like really great with, actually, and it's like really transformed how we actually develop in that way.
Wow, quite interesting. So when we did serverless project before, we used Aurora. How can you determine which database to use in AWS if you're starting out a project? I would assume, like on an architectural level, John, you can actually make recommendations on, which AWS technologies can go with, which right database, right? And you get to save a lot rather than buying like license from Oracle. You can opt to buy it, using the AWS technologies, right?
Mm-hmm. That is definitely, yeah, very great point in terms of Aurora and other relational databases, is that they tend to be ANSI SQL based, thinking like MySQL, PostgreSQL, and so on. And so you can generally like put your code into one database, you can migrate it to another. There are a few things like if you had functions that might be a little bit more difficult, but they're very easy to like pick and choose between them. In terms of then architecting between them, and I should say then, whereas DynamoDB is very much an AWS only technology, it does accept JSON payloads, and I think it is now MongoDB compliant, but I'm not 100% sure there. So at least it's getting a little bit easier. If you felt that you wanted to migrate off DynamoDB, you can like at least host your own MongoDB cluster if needs be. Architecting, there's lots of discussions about whether or not when you should utilize NoSQL versus SQL-based database. It really comes down to your actual overall application and so on. I'm generally a big fan of larger applications. You have a lot of relationships between your data and so on. I would tend to actually just go towards SQL for that, as I would generally also end up building more complicated queries to like get information out of the database. DynamoDB, I tend to be very like one-to-one mapping between like a feature and a table effectively. If that made any sense. Sorry.
Yes, it does, John. Thank you. Thank you for recommendations. We have 3 questions for you, John. So from Ace Mangalino, he was asking like how DynamoDB is built. Is it available in free account?
Great, yeah. So by default, it is built in, was it pay per request? It is like, so you can set the capacity effectively. I mean, I think in my example, they might be like read write capacity of 5 and 5. So each request does count. It is available in your free account. I would have to double check how many read and write units you get for free. They do apply to your entire account. So for instance, say, making up a number here, if there was 1,000 read and write, free read and writes, you know, if you had 10 tables, it's like, it will be just divided up, whoever, like, you know, if they're all being used and so on, the 1,000 will go very quickly. If you only have one table, it's again, they'll have 1,000 in itself. That was very poorly worded on my part, but and then you can do a few other changes in terms of DynamoDB. I believe you can set it up to be the requester pays, but I would have to double check that.
Okay. When you say pay per request, John, so on the actual usage only, right? So you don't need to pay a fixed amount to be able to use DynamoDB, right?
Correct, yes. It's literally as the request comes in, as a read or a write action occurs, only at that point will you get charged for that specific action.
Yeah, so it means whether you're a startup or you're an enterprise, you'd be able to save a lot on this because you only pay per request. Correct. All right. For the second question from Maguntan, what is max memory we can use for serverless applications?
Oh, I would have to double check the total max memory. Since they brought out Docker, I believe it went up into the gigabytes, I thought. But I can't remember if I'm thinking about the size of the Docker image or the actual like memory itself. But I believe it's gone up significantly over the years now.
Yeah, I would
think like
say so as well.
And then I believe also like the timeout is something like 15 minutes or so also.
Yeah, and it keeps on improving also, right? As you know, we go by. There's another question, John, from Jaira. Which would you recommend using when invoking Lambda to DynamoDB? DynamoDB table. Is it DynamoDB table plus Lambda plus API gateway, or DynamoDB streams plus event bridge plus step function?
Great, like I'm a huge fan of step functions. For people who don't know, step functions are effectively a mini workflow of Lambdas. So you can create you can orchestrate like one Lambda going into 2, into 3, and so on. And you can actually configure very complicated, if you wanted to, logic in it, saying like, great, if the first Lambda actually gives a certain response, run the second Lambda or the third Lambda and so on. Like I would definitely, it feels like how much more processing are you doing within it? Like when there is, if you find yourself, you are chaining multiple Lambdas or you're putting too much logic into one Lambda, I would definitely, yeah, I'd agree. Going with step functions would definitely be the way, because we do want Lambda processing to be pretty specific. You really should be thinking about it in terms of a function, because you are when the Lambda actually runs, you are being billed for the length of time that Lambda is processing. So the shorter we can make each individual Lambda, the better. If a Lambda is very large and it's pulling in a lot of libraries and so on just to start up, that will, I mean, we're still talking milliseconds, but it could add up if you have the next big game or something.
Looks like you're not the only one who's a step function fan, John.
Oh, excellent.
But very, very helpful. If you have more questions for John, please feel free to ask in the chat. And John, hopefully I can, you can still stay for a little bit to answer some questions. And I really love your hat, by the way.
Cheers. Thank you very much. Yeah, I'll be around.
Thank you again for sharing about DynamoDB. All right, everyone. I hope you're learning a lot from our speakers. So we have our third speaker who will be sharing about sorry about that. We'll be sharing about Amazon EKS. And while he's preparing his deck, let me introduce him. Okay. Aman, are you ready?
Yes, I'm ready.
He is. All right. So Mr. Aman Bakwana is from Rajat, India. And Aman is a DevOps engineer, AWS certified as well, and Azure certified. So he's an Aviatrix MCNA certified. We'll ask him about this one. And then an AWS community builder and CNCF leader Rajat group. All right, without further ado, everyone, please give Mr. Aman Bakwana a round of applause. Welcome, Aman. Thank you for accepting our invitation to speak at tonight's meetup.
Okay, so first of all, hello all from India. And thank you, Shelly, for giving us a nice opportunity, and also AWSUG Philippines group for giving this nice opportunity to speak. Without quickly wasting time, I'm sharing my screen. So let me know once it's visible, so I can start upon that.
Looks good, Aman. Go ahead.
Okay, thank you. Okay, so here we will discuss about the agenda and flow of our presentation, which will be looking like introduction and agenda, that what we are going to do, then why containers, and then what is EKS, and what is Kubernetes, and why we are used and why we should use EKS managed service, and which is and I will getting about the EKS overview and roadmap, and then will be followed by Q&A. Okay, so this will be the introduction slide, as Shelly has given the very nice introduction of me. So, so I am speaking this slide. Okay, so let's start this presentation with one nice quote, which is by Containers and Docker, which is develop, ship, and run application anywhere. So this quote stands right where we, whenever I have a Docker image in my hand, then I can ship my application anywhere. Then I can also run my application anywhere on any platforms, right? Okay, so why I should use containers? So the containers has many advantages, like what we can say, just a minute. Okay, so it gives us speed and efficiency. Like yes, containers gives us speed and efficiency. Just I have to give my container image to someone else, and they have to just fire one command, and then whole container is up and running. The second one, then we go to the second one, which is easier packaging. So what is the easier packaging? The easier packaging means whenever we are dealing with any application, we have to create one container. So the container is nothing but a packaging of whole application code plus those required dependencies to run the applications up and running and run smoothly and accurately for what they are meant to do. So with container, we require it follows us like an easier packaging. And third one is less risky deployments. Yes, suppose I need to scale up my code, right? So I don't need to boot up another server and sort of do some same configurations again and again and have my applications again up and running. So what can do here? I can have a container, and I just have to say that take this image and do up the container. So this will be the scene here, where it will be followed by less risky deployments. Also, we get a better development experience. And also the last but not least, which is microservice architecture, which is very booming and buzzword nowadays, where microservice consists of only and only containers. Okay, so moving on to the next slides. So what are the other customer use cases of containers and Kubernetes? So as we discussed, microservice is also one use case, where other is platform as a service. So what is EKS? EKS is a platform as a service, where Amazon gives us the whole EKS cluster, and they have an access for master plan, whereas we have to just take care of our application only, that our application should be up and running as per desired state. Okay, so third one is enterprise app migration. So whenever any of the organization or company has to move their code base to the to the containerization or the Kubernetes platform, then they can done it in a very easy way. And fourth one is machine learning. Well, large models taking around huge amount of time to and also taking huge amount of compute and memory resources, which will help you in this use case. Okay, so what are the AWS container sites, or we can say service landscape? Where the first one is Amazon ECS. So ECS gives us a management of the underlying containers, where we can deploy, schedule, and also maintain the scaling of the application. We can say containerized application containers. And also it has EKS, where we can also manage deeply about the containers, each and every containers, and bound to some resource memory limits and something like that. And also it provides us very higher amount of scaling. So hosting, where the containers run. So if we see from the AWS side, then containers run on the EC2 instances. EC2 is nothing but some servers, and also it can run on the Fargate nodes, which is on serverless side. And also it provides us an image registry, where we can store all our images and do some interactions with that. Coming to the next slide. So now, what is Kubernetes? So containers are always there, but to manage the container or to scale the container at higher scale, we somehow getting an issue to maintain the scaling, right? So there comes the Kubernetes. Kubernetes is nothing but a container orchestration tool, where I can better manage all my containers at an easy level, or I can say it as a configuration level. So it is an open source container management platform, which is developed by Google, and also it helps you to run your containers at scale. Yes, we can get very nice or very higher amount of scaling with Kubernetes. And also it gives you the primitives to build modern applications on modern infrastructure. Yes. Okay, so where you run your Kubernetes, that matters. So how it matters? Amazon gives us an EKS, which is a managed service. So what is managed service and what is unmanaged service? So whenever we are deploying any Kubernetes cluster, it is a major headache for any organization to maintain that Kubernetes cluster, because Kubernetes cluster is contains of many small components, and availability of each and every components matters, because Kubernetes is fetching and data from each and every component, and every component is working very tightly. So whenever so where you run your Kubernetes is matters. Like if you are opting for Amazon EKS, then it gives you full on assurity that your Kubernetes cluster will never goes down, because they maintain a high availability, which will we show you in next slides. Also, so as per the recent surveys, this photo was downloaded from I think 4 or 5 years back, where 51% of the total Kubernetes workloads runs on AWS EKS, which is a CNCF graduated tool, and also this number was given by CNCF only. And now, and as per now, this ratio was increased up to 60 to 65%, and this was a great good deal for Amazon as well as an AWS EKS service. Okay, so what's apart from EKS, what EKS features are there, and what kind of EKS ensures that your application or your cluster should be always up and running? So there are this is divided into 4 main points. That is, EKS is a platform for enterprise to run production grade workloads. Yes, it is certified production grade workloads. You can highly trust on EKS to deploy and host your we can say highly scalable workloads. And then second point, which is an EKS provides a native and upstream Kubernetes experience. Yes, the it provides a highly updated experience. The Kubernetes EKS is actively working on newer and newer versions of Kubernetes, and you get the each and every flavor of the versions which is releasing in Kubernetes. Also, third one is provide seamless integrations. Yes, as EKS is a service of an AWS itself, so you can also integrate many other services with EKS also. Like you can integrate EBS for volume provisioning, and also many other services like Route 53 for DNS purpose, and many other services as per your workload and as per your applications. Okay, fourth one is it is team, and EKS team is actively contributes to the Kubernetes projects. Okay, so as I have said that you can get an each and every flavor of Kubernetes version which is released, and also they are actively increasing the features every now and then. Okay, so as I have told that EKS is Kubernetes certified. So what is Kubernetes certified here means that it can guarantee the portability and interoperability, that your cluster will never goes down. It has an SLAs of 99.99% available. It can get timely updates, as I have mentioned that you can get an update of every version's worth of Kubernetes installed, and it can give you the confirmability that your application should be always stay up and running. If any of the server goes down from their side, you didn't get any, your application doesn't get affected. Okay, so here gives the EKS architecture overview. So here is the so whenever you launch an EKS cluster on Kubernetes, then AWS on their behalf side done these following things, that Kubernetes has an API server which is an highly sensible component, and also an HCD cluster which is a key value store of the Kubernetes server Kubernetes. So these both are very highly sensible we can say components of the Kubernetes. So AWS does ensure that they will keep 3 API servers for the 3 copies of the API servers, and they maintain the high availability of your cluster, and also the same for an HCD clusters as well. So here is the EKS highly we can say bird overview of the architecture. Now coming to the features of the EKS. So EKS is a managed control plane. So whenever we come to the Kubernetes platform, there are 2 main components, which is a master plane, which is an worker plane. In master plane, Kubernetes hosts their components like API server, HCD cluster, controller manager, kube proxy, and many like networking or security like plugins. And in EKS features which is managed control plane. So EKS is controlling whole those master plane components, which is an which is we can say that an HCD cluster and API server. So Kubernetes AWS is managing the whole thing. So we just have to carry we have to just worry about our workloads only. The second one is service integration. So you can integrate with multiple AWS services as well. So you can get an also hosted Kubernetes console, where you can by seeing the console itself, you can able to visualize that I have this much of the namespace and this much of the workload as of now deployed. And also you can get an EKS add-ons, which add-ons is nothing but an like if you want to add an EBS volume with your application, then you can also add an add-on of an EBS. So on request of your YAMLs or configs, they can provision an EBS. Also the managed node groups, which is nothing but managed number of fleets of instances, which is managed by AWS itself. And also an EKS CTL, which is a command line utility management, by which you can interact with your cluster, and also you can with command line, like if you want to cluster create the cluster, then EKS tells create cluster and the necessary arguments which is needed to provide it. And also it supports underlying instance with many CPU architecture, like which support ARM CPU architecture, Windows CPU architecture, and many more. So if you look at the other features also, then let's say, okay, so these are the other features of this of the EKS, where we get and support for in networking and security model, we get and support for IPv6, which is also good. We can also get an AWS in-depth inbuilt service discovery. We get some service mesh. We can also integrate with that. We can also integrate with an VPC native networking. We can also, and let's see on security side, then we can also use an IAM authenticator, IAM for service accounts, and also we can get an compliance. So it has many features. We can also integrate it with load balancers also. And on serverless side, we can also do some hybrid deployments. Recently, AWS has launched that you can also connect your EKS cluster on premises or any in other cloud providers also to an AWS. So which is very nice feature. Then they also provide logging. So logging is a very integral part of any application or any cluster deployed. So how can we get an idea about our deployed architecture? So here loggings come into the picture. So Kubernetes EKS also provides a logging to each and every component. And as I mentioned, that it can also provide and manage cluster updates. So let's move towards the presentation. So this was the features of the EKS. Okay, so here are the EKS architecture diagrams for your perspective, that how EKS diagrams are there and how they are actually deployed. So let's take a look at that. Okay, so this is the very simple architecture where I have an EKS control plane, which is whole and sole managed by AWS, which resides on one VPC, which is in one network. I have one ECR repository, which is responsible for storing my Docker images, and also I have another where my client resides is also in another network, and I just have to take care of this VPC, where I have deployed my private subnets, and I also deployed my worker nodes in private subnets. So I just have to take care of this network only, and all this EKS control plane and is managed by AWS. So ECR is for storing and Docker images. So this will be the typical Amazon EKS architecture, and which is a very simple architecture. So coming on to a high level architecture whereas we have mentioned that EKS is whole and sole managed by AWS. So control plane is managed by AWS. This VPC is managed by us. So we have to take care of this, and that what we are deploying, how we are deploying, and how we are doing the configs, and we are whole and sole responsible for this part, this chunk. Okay, so this is high level architecture where I have many things set up in my cluster, where it is like traffic application, traffic load balancer, and application load balancer, Fluent bit for metric and data collection of the worker nodes lying there or infrastructure. Other is one new relic, which is also a monitoring solution, HashiCorp Consul, and I can also integrate Kubernetes cluster autoscaler, where if the load under my cluster is higher than my cluster autoscales, then cluster can add nodes and remove nodes onto the basis of the capacity. Also, we can install Kubernetes dashboards, metric server for further scaling of the pods and containers. And also we can integrate with other AWS services like Route 53, ACM, IAM roles, Lambda, Systems Manager, and S3. So this was very high level architecture of the AWS EKS. AWS EKS is very nice service, and everyone is adopting nowadays due to the booming of Kubernetes. Okay, now moving on to the presentation. Okay, so this was it, a bit introduction and a bit broad overview about Amazon EKS. So any questions, guys?
Thank you, Aman. Well, we're waiting for questions for you. Can you share your journey into AWS? How did you get started?
Okay, so when I was passing my college, I have one subject introduced, which is which deals with AWS and cloud computing. So where I started to learn in AWS, and after starting learning, I get into deep because I'm always trying for in order to learn just backend things. So
I see.
getting interested, and then I was joined one company, and then projects are coming on, and I worked on several projects on which is solely deployed on AWS and cloud platforms, and also cloud native applications. So there I've started my cloud journey.
Wow, interesting. So you were a software engineer prior to being a DevOps engineer.
No, I'm a DevOps engineer from
Okay. So
starting.
right from the start, you're a DevOps engineer already. Wow,
Yes.
interesting. Okay. Does anyone have any questions for? Oh, there. Okay. So from Maguntan, what is a monitoring tool we can use except CloudWatch? Is there an alternative to it?
Okay. So apart from CloudWatch, you can also integrate. Prometheus, and you can export those Prometheus data to a Grafana dashboard. So you can better visualize the whole thing or whole cluster. And there are also many monitoring solutions available. One is Prometheus, which is open source. Second one is New Relic. Third one is Datadog. These all are the major tools you can integrate with your cluster in order to have insights of your cluster and your application. Hope I've answered your question, Mukundan.
While we're waiting, if there's a follow-up question from Maguntan, Jaira has sent in a question. While ECS is easier to deploy, EKS somehow requires experience when setting up clusters, except for configuration, trial and error. Any advice for people starting to explore?
Okay. Okay, so Jaira, here my advice goes to first of all, before launching an EKS cluster or before starting to learn direct EKS, first of all, you jump on to learn in Kubernetes, that why Kubernetes has arrived, and then you go to deploy and start to deploy an EKS cluster. Yes, EKS cluster is a bit tricky at first sight whenever we are launching an EKS cluster on very first day. It is a bit tricky, but you can go on somehow by following AWS. AWS itself has a nicer set of blocks while setting up an EKS cluster.
Were we able to answer your question, Jaira? Okay. So Maguntan, were we able to answer your question as well? So let us know. Are there any more questions for Aman? Aman, yeah, if it's okay for you to just hang out with the rest of the team so that in any case somebody asks questions, you can still answer it. Is that okay?
Okay, sure, not an issue.
All right. On to our last speaker for tonight. And thank you everyone for, staying throughout all the interesting topics and speakers. And I really want to thank them for their time and expertise. Okay. For our last speaker, let me share my screen. All right. For our last speaker tonight, we have Mr. Arun Kumar Manan. I hope I pronounced his name properly. So Arun Kumar is a solutions architect with a solid cloud migration background. He loves take end-to-end responsibility and deliver the results on time. Expert in handling requirements, gathering, assessment, execution, and production deployment. Highly interested in rebranding implementation, creating POCs or proof of concepts for various use cases and the 7 R's of cloud migration. Experience in developing or managing client relationships and providing unmatched customer service. Without further ado, we have Mr. Arun Kumar Manan from New York. Hi, Arun. How are you? Okay, let me stop the screen share so that you can share yours. You're on mute, by the way.
Yeah, hi.
There you
Doing
go.
great.
Thank you for waking up early, although I would assume it's now 8:30 on your, almost 8:30 on your end, right?
That's okay. So
All right.
it's always like examination, the last day preparation. So yesterday I'm till night 2 a.m. I was preparing for this.
I hope you have your coffee ready as well.
Already had.
Okay, done with it. Okay, let's give everyone. Let's give Arun Kumar a round of applause, please. Thank you. Go ahead, Arun. You
Great,
can share your
guys.
screen.
Yes, I'm doing it. 1 minute. I hope you all can able to see my screen. So my name is Arun Kumar Mannan. I started my career as a system administrator. I do have some 17 years of IT experience now. Since I started my journey as a system administrator, I literally handled the ghost images by using the floppy drives. And most of you couldn't even see the floppy drive. So over the time of period, I started my journey as a middleware administrator and used to handle the 3-tier architecture. And so time changes. So clients, they decided to move their on-premises application from their own data centers to the cloud. So that's where I started my cloud journey. So to move the application from on-premises to cloud, so there is set of the requirement gatherings and definition of then and the proper planning from load balancer till database. So everything needs to be carefully planned. So luckily, since I do have experience in this journey, I had a chance to interact with all the interfacing teams and had a chance to work on the cloud migrations. I'm handling these cloud migrations almost for the past 6 years. AWS defined the 7R: retain, relocate, refactor, replatform, retire, and totally 7 Rs. So whatever the applications we are having in on-premises, everything depends on one of these R categories. So based on this R category, we have to move the applications from on-premises to cloud. It depends on the R, the definition of done, which means the set of tasks which you need to implement will vary. Let's move to the next. So here we are seeing the differences between the on-premises and infrastructure as a service, platform as a service, and software as a service. If you see in on-premises, and you have to manage everything, so network, storage, you have to buy the servers, and you have to implement virtualization solutions like VMware. You have to install your operating system like Linux or Windows, and install the middleware components like Tomcat or WebSphere application server, runtime like Java, and then you have to install your applications on top of it. So, which means you have to recruit a resource to handle all these components. That is what we did so far, almost, more than some 10 decades. So now let's come to the infrastructure as a service. So when it comes to infrastructure as a service, just imagine our AWS. They themselves handle the networking, storage, service, virtualization, which we don't really need to, as a user, we don't really need to worry about it. We just need to choose the operating system and install other components. So all the red components, the cloud provider will take it, and all the remaining components, as a user, we have to take care of it. So that's the beauty of the infrastructure as a service. So when it times evolving, then the platform as a service arrives. That is what we are going to discuss. Almost most of our experts, they told about the containers. So the one what we are going to discuss also comes under platform as a service, which means all the red color components which will be managed by AWS, and we are as a developer or the user, we have to focus only on our code. Just have the code ready, run it. So ECS, Elastic Container Service. Now, I mean, someone mentioned about EKS. So everything is using the container concept, and the both products will come under platform as a service. Software as a service, everything is ready. For example, so we can say Salesforce, or a simple example is Gmail. Gmail is giving you just need to create a login and password, and you can start use the service. That's it, right? It's a software as a service. Let's quickly jump into the topic which we're going to discuss. It's a Fargate. Fargate, so we can even say it's a serverless, and so it's a platform and pay-as-you-go compute engine, so which will help you spin up the container instance. For example, in this case, all the components is managed by AWS. Even on top of this, so we don't really need to worry about managing the components like the virtual machines and everything. So everything is managed by AWS. We just need to worry about focusing on only the application deployment. So we are going to see the hands-on demo. So Elastic Container Registry, it's similarly like Docker Hub. So you're storing application developers, they don't develop the code, and you are Dockerizing the code by using Docker, and that image can be pushed from your Docker or from any EC2. So the Docker can be installed on your local machine or on any Linux machine. So in my demo, I'm going to use the EC2 instance, the Linux EC2 instance. I'm going to push the Docker image from EC2 instance to ECR, Elastic Container Registry. So as the name suggests, it's an image, it's storing the images like Docker Hub. So this is the architecture diagram which I created exclusively for this demo. So as an administrator, I'm going to the EC2 instance, which which I already created. I'm going to install the Docker on top of it, and I'm going to create image. The image, whatever I'm creating, I'm going to push into ECR, which means Elastic Container Registry. See, this is VPC. So Elastic Container Registry is out of VPC, but it's in the same region. And once the image is available in ECR, so AWS Fargate, so it's a serverless engine, so which will take the image from Elastic Container Registry and spin up the containers. So which AWS, it's a self-managed service, highly available, scalable. So we don't really need to worry about spin up any EC2 instance. So AWS will take care of creating. So just think about the power of Fargate, so which will spin up 3,500 containers in 4.5 minutes, as per the latest research from one of our AWS hero. So within 4.5 minutes, it spin up 3,500 containers. So powerful. If you use Lambda, it's even very less. So within 0.5 minutes, 3,500 containers will spin up by using Lambda. So Lambda also serverless service provided by AWS. So once the image is available, so Fargate will take the image and spin up the container and two availability zones. So availability zone 1 and availability zone 1, 2. So since you have two availability zone, it's a highly available. So even though one availability zone it goes down, your application will not get impact. So production applications will keep running since you have the highly available configured here. So once the setup is ready, the general users, they are going to hit the Amazon application load balancer public URL. And since the name suggests, it's balancing the load. So since you hit it, the load will split or balance into the two containers which is running. So that is what we're going to see now. Let's jump into a demo. So I have my EC2 already created in my console. The EC2 is already up and running. It's just 2 minutes work. I mean, just click launch instance and go next, next, next. That's it. It's a cool feature. So virtual machines. So in real time, if you need a server in on-premises, the process itself will take minimum 3 weeks to 6 months. But here you have the liberty to come up with any operating system or any instance type within a few clicks. That's the power of AWS. It's public cloud provider. So for my EC2, I do have a public IP address, which I used here to log in. So I already logged in now. Now let's jump into focus on the Docker. So we're going to create some simple application and then we're going to push into the ECR. I do have my Docker file ready already. So here is the simple application which I'm going to run. So after running, I'm going to get a message like hello AWS UG in the browsers. That's what we are going to see now. Go and build the Docker build. I'm building the image by using Docker file. And then I'm using the filter and reference. Now my image is ready. The name of hello-AWS UG. And I'm going to run my Docker container now in my EC2. That's it. G is missing. Let's try to hit. That's it, cool. So now, if you see my EC2 instance already configured with the public IP address, and I have installed Docker and I have created a simple image. And in the simple image, I just mentioned the word called hello AWS UG. If you see in the file, I'm just going to echo only the word called hello AWS UG. And so once the Docker is run, I'm hitting from a browser, which is showing the email. So what are the message which I configured? Hello AWS UG. So let's go back to the architecture diagram. Now I can able to hit the application which I installed here in Docker. Now, the next step, I'm going to push into ECR. So to see, I'm using my region called Oregon, and which is in US-West-2, and what I'm going to do is I'm just going to create a new repository in the name of hello AWS UG repository. So in the meantime, we just discussed about ECR. It's the Elastic Container Registry, which is going to store your image. So just type ECR here and you will see the service called Elastic Container Registry. Open here. If you see, there is no images so far. I haven't created any repository. It's empty now. So just go ahead and hit it. Boom. It's created. You have the new repository ready, but the repository doesn't have an image now. So let's go and push the image. And before that, we have to tag the image with the repository, and we did tag now. So don't worry, I'm going to create a detailed blog, maybe in a few days, and I'm going to publish with the dev. So I'm going to publish in my LinkedIn too. I'm going to publish all these comments as well. So we're just logging into the ECR by using the username and password. It's a token authorization. So now it's connected with ECR. So let's go back to image architecture diagram to understand. Now we are connecting with ECR and we are going to push the image from EC2, the Linux EC2 to ECR. Docker push to the repository. So we started pushing the image from our EC2, the Linux EC2 to the Elastic Container Registry. So fast. So also 139 MB image, which is push now, go here, refresh. We see the image now. The tag is called latest. Okay. So good. The next step is now we do have the image pushed into Elastic Container Registry. Now it's Fargate. Fargate is a serverless component, and it's we're going to, if you type Fargate, you will not get any service. So it's Fargate. By using Fargate, you can use Elastic Container Service ECS or Elastic Kubernetes Service EKS. Okay, let's click ECS. We're going to use, see the demo by using ECS now. Go here and click cluster. Do we have any cluster? No. Just click create cluster. So cluster is straightforward and it won't ask much your thing. So just need to select the network only. It's going to use the AWS Fargate. We're not going to use a manual approach like the Linux EC2 or the Windows. We're going to use the Fargate. So choose networking only option. So click next. Cluster name. Maybe we can AWSUG -cluster. Leave everything as default. I'm not going to do any special configuration now for this demo. That's it. Your cluster is ready. So once the cluster is ready, so cluster, you have, I mean, you see the services, task, and ECS instances, everything. But as part of the Fargate, we are going to create a task. So to run the task, we need a task definition. So just imagine the task definition is a big box, and within that, the containers are running. It's a small box. So the task definition is the template. Go ahead and create task definition, which I already created yesterday for the demo. Let me quickly create a new definition. Go ahead. So for the task definition, choose the template, Fargate. Click next step. Write the names. So there's a lot of names we need to remember. So that's okay. Task definition and select the role. By default, so it will come. So no need to worry. So task definition name we just mentioned, and operating system family. I'm using my Linux execution rule. I'm not touching anything. So here the fancy. So you have the option to mention the memory from 0.5 GB to maximum 30 GB. So go ahead. For my task definition, I'm configuring task memory is 0.5 GB and 0.25 vCPU, which is more than enough in my case. So click here. Add container. So in ECR, if you see, we already have the image. Every image has a URI. So just click and copy. Go to, give some name, AWSUG container. Mention the image repository and copies, whatever we. Memory limit, we don't really need to give anything. Port mapping or container port, let me give 80 so that we can able to access from our browser. Apart from that, I'm not configuring anything. Let's go ahead, leave it everything as it is, the default. I'm adding my containers. Here you go. We have the container and the image, everything is configured under the task definition. Task definition, let me give some different name. For example, task definition 1, because I already have the same name definition already. So let's create, and we have the task definition is created. Go ahead and click view task definition. It's there. So click cluster, you see the cluster created, and inside the cluster, click task and nothing is there. So what we can do is run a task. Now we have a template ready and the cluster ready. The next step is we have to run the container. So click the Fargate, operating system is Linux, and choose the one which we created. Task definition is AWSUG task definition 1. Number of tasks, let me mention just one for our demo. VPC and all, I mean, leave it as a default. Subnet, I'm going to choose 2. I don't think so. Let me mention the number of tasks is 2, so that you will get 2 instances, which will be the high available. Auto assign public IP, so please make it enabled. So or else we will not be able to access it from our browser. Click run task. And now if you see the status is provisioning, since I mentioned 2, you see the task 2 tasks are getting created. Go ahead and refresh. It may take few seconds. Now we are into this stage. So Fargate is pulling the image from here and creating the container 1 and 2 in 2 availability zone. So we're still in pending status, and go ahead and refresh. Boom, one is running now, another one is still pending. So whatever is running, I mean, both are running now. So click the task and you see the public IP is created. While creating it, I have mentioned like we have to choose it. Copy the public IP, go to open a new tab, run it. Boom. So you have the, now we totally tested 2 scenarios. We hit the Docker image, so that was working. And now the image is pulled by AWS Fargate and the 2 containers were up and running, and we are hitting the URL, and that is also working. The last scenario, we are going to create the application load balancer, and the end user will hit the application load balancer. So the application will be accessed here, I mean, from one of the containers. That is what we are going to do as a part of next step. ALB, Amazon Load Balancer. Type load balancer, and you will see 2 options. The one is for light sale, which we are not going to do now. Choose the EC2 feature of load balancer. Create a load balancer. Choose Amazon Load Balancer. Create AWSUG-LB load balancer, internet facing, since we are going to access from internet now. I'm going to leave most of them as it is, and I'm going to choose 2 subnet. VPC is my default. Security group is also I'm going to leave with default. And port number, which I'm going to mention. I mean, here the fancy is. So create a target group, which we need to create a target group. So what is target group? Whatever the hit is coming to load balancer, it should know where it should route the request. So that is why we are creating the target group. Okay, go here, go to target group. We are using Fargate. Fargate has the IP address, right? So we are choosing the IP address here, and port number is 80 by default. The target group name AWS UG-target group. Leave everything as it is, default. Next. Now I'm not going to change anything now. Leave everything by default. Create a target group. That's it. It's created now. AWS UG target group. Now the load balancer will know where to redirect the request. So choose the AWS target group. And you do have the listener port number 80 configured. So which means you're hitting the URL in the port number 80. From 80, the container is also running in the port number 80. So the application also routing the request to port number 80. I'm not changing anything. Let me create a load balancer. It may take a minute. Let's see. So provisioning is in progress. And in the meantime, let's go to cluster. And here the important concept which we should understand. So cluster already has some 2 tasks which is running. Okay, now we are going to create a service because the load balancer can't able to send the request to task. Okay, so here the 2 tasks is running. We will not be able to configure this task with the load balancer. So that is the reason we need to create a service. Go ahead and create a service. Launch type is Fargate. And the task definition, which you mentioned, task dev 1. Let me choose that. Come on. I'm not able to choose. Use the latest, the task definition 1 for some, oh, good. So I have selected my task definition 1, whatever I created, cluster. I'm leaving everything by default. Let's mention the service name is AWS UG-SVC and the number of tasks is 2. Already 2 tasks is running. It will create 2 more tasks for your information. Let's click next step. And the next step, we will get an option to select the VPC and the subnet. I'm going to choose 2 subnet. The reason is high availability. What's happening? Okay, security group is there and auto as an IP. The public IP is by default enabled. I'm not going to touch that. And load balancing. Select the application load balancer. See the architecture diagram, we are using ALB and by default it's came up in AWS UG-LB. So now the load balancer know where to route the request. The listener port, the target group name, everything just mentioned here. The port number is 80. I'm not going to change any other point. Do not adjust the service desired count. Okay. Click next, review everything, create service. So now we do have services up and running. If you see, go to the cluster, under the cluster, we have the service is active now. And if you go to task, you see totally 4 because already I created 2 manually. Now the service I mentioned 2, which is in progress of provision. Go ahead and click it and it's in pending state. Let's wait for a minute. And in the meantime, let's check the status of the load balancer. Load balancer should have been created now. state was provisioning, hit the refresh, and it's active. So the load balancer is also up and running now. Let's wait for a few seconds. Now the new task is also running. Go to load balancer, take the DNS name, open a new tab, boom. So 3 scenarios we did test. So the first scenario, we hit the Docker image directly. That is what here. So this is my the IP which I used to test this scenario. And then AWS Fargate pulled the image from ECR and the container came and up and running, and we used this IP to test the scenario. And the last scenario is we created Amazon load balancer. We used ALB public DNS name to hit from internet. That is what we are hitting now. So all the 3 scenarios we did test. As a time check, that's it. The demo is completed. Any questions?
Wow, that was really, really cool, Arun Kumar.
I'm really sorry, it's so heavy for the short duration.
No, it's interesting that you were able to actually, have an actual demo on how to use Fargate. Does anyone have a question for Arun Kumar? I think they're stunned with Fargate. Arun,
Don't worry, I'm going to create a detailed blog. I'm going to publish in my LinkedIn.
yes,
few days,
please
maybe
do,
maximum by
please do, so that we can reshare it also to the attendees. What are the best practices for ECS Fargate? I mean, what are the things that they need to avoid, and what's the easy, not really the easiest way, like at least a couple of best practices that attendees
The
can
number one,
try.
the number one best practice is we should not create anything in public subnet. Everything should go into the private subnet.
I see.
So the components will use the interface endpoint to interact with each other. For example, here the EC2 in the private subnet will use the interface endpoint to communicate with ECR. So to be frank, it took almost 2 months to set up such environment in the private subnet, but in a public subnet, I can able to show you demo so within 20 minutes. But if it is a private subnet, there is a lot of process to be followed, and definitely it's time consuming. The best practice, do not create anything in public subnet.
Okay. Jair said, my head is still spinning from all the setup. Don't worry, we're gonna post this in our YouTube channel also, so everyone can review. But if anyone has any questions after the meetup tonight, hopefully they can reach out to you via LinkedIn. Am I correct?
Yes.
All right. Thank you, everyone. We really appreciate joining us from the start till the end. Can I ask our speakers for tonight to turn on their cameras again so that we can have a group photo? Let me check if I can ask everyone to turn on their cameras as well. I'll just change the setting. All right. I think everyone can turn on their videos. Feel free to turn on your videos, everyone. There. Princess was able to open. Anyone else? Has Aman left already, or he's still here? Okay. All right. Wow. Okay. More and more guys are turning on their videos. So we have a lot of attendees from ACT. So everyone, thank you for joining us. All right. Last 5 seconds to turn on your videos. Cool. All righty. Okay, ready for the picture? 1, 2, 3. And we have for the second screen. All right, 1, 2, 3. Thank you, everyone. Thank you again to our speakers, to John, to Adeline, to Aman Kumar, and Aman as well. Thank you very much for sharing your knowledge, your expertise, you woke up really early and, from different time zones. So thank you so much on behalf of AWSUG BuidlHers Plus. So we'd like to thank everyone for their time tonight, and we hope to see you next month for our next meetup. Thank you. Have a great evening, everyone. And those who will
Thanks,
be
everyone.
requesting for certificates of attendance, don't forget to fill up this form. I'm gonna reshare it again in case you missed it. There you go. So there's a form again. Just fill it up and then we'll send you your certificates. Again, thank you, everyone. Have a great evening. Bye. Thank you.
Thanks, everyone. Bye-bye.
All the organizers of AWSUG BuidlHers Plus as well. And happy birthday, Jaira.